In this video, I'm going to show you an example of the general addition rule, once again, or kind of all the probability rules up to the general addition rule for speeding tickets, as you can see right here. So in this table, I've got speeding tickets for both male and female, and how many of them had 0 tickets, how many of them had one ticket rather. How many of them had 2 speeding tickets, 3 speeding tickets, and then these columns over here, this column over here is just a total, as well as this row is also totals, right? Totals for the 2 columns, 2 rows above it. Okay, so let me just quickly review something with you that we're going to need throughout this problem, and that is this is the general addition rule, something that you should know. All right, and the way that this works, again, I showed this on a previous video, is if I was to show you here a Venn diagram, let me draw a Venn diagram here, right? And E and F will make these 2 circles represent these events E and F. All right, so the probability of E is this first circle, the probability of F is the second circle, and this thing right here is the probability of E and F. That's considered the overlap. Right, so where they intersect, where they overlap with each other, must be taken away because you don't need to count that more than once. Right? You don't need to count that twice. Hey, real quickly here, if E and F are mutually exclusive, right? If what one author calls disjoint, then this is the picture. Here's the Venn diagram. Here's E and here's F. And since they don't overlap at all, there's no overlap whatsoever, this probability right here would just be a 0. Right? Probability of E and F, well, they don't overlap at all, so that would just be a 0. And if that last term is a 0, you could see that we're just simply going to add up the probability of E and the probability of F. Right? That's just a real simplified form of the addition rule. Only if their overlap is not there. Right? There's no overlap at all. Okay, so that's the general addition rule. So here's our first question. The question is, can you find the probability that we randomly select a driver and the driver is female? Right? That the randomly selected driver is female. Well, that's not so bad. First of all, how many female drivers were there? 115. Right? 115 female drivers. So we'll put 115 on top, over our total number of drivers. In this case, it's 197. There it is. So we'll put that over 197. We'll crunch that out on our calculator, and you can see that this comes out, whoops, here we go. This comes out to be 115 divided by 197. Roughly, if we were to go to 3 decimal places, 0.584. All right, so 0.584 if we were to go to 3 decimal places. So I'll put that here, 0.584. Alright, so that's just randomly selecting a driver, and the driver happens to be female. So 115 out of 197. Okay, slightly different question now. How about this one? What's the probability that we randomly select a driver and that driver has been issued 1 ticket, right? And only 1 ticket. So we're looking for this one right here. It's not the rows this time. We're looking for, hey, male or female, it doesn't matter. There were 21 people, right? Male or female, it doesn't matter. There were 21 people who had just 1 ticket issued, so it's going to be 21 out of 197. So it's going to be 21 out of our same old total of 197, which is right there. And we have a different percentage this time. So 21 divided by 197 gives us, if you round to 3 decimal places, we'll call it 0.107. Right? I hope you can verify that on your calculator. Okay, so that's randomly selecting a driver who had only 1 ticket. Let's change up the problem once again. Now these are going to be a little bit trickier here. How about this one? Randomly selecting a driver who is female and was issued 1 ticket. Right, who was female and issued 1 ticket. Now there's only one spot. I hope you see this whole row represents female, the red row that I have here up at the top, 97, 14, 3, 1. That's our number of females. And right, this is our column for 1 ticket. So they intersect. I hope you see that. the intersection of these two is right here. It's right here at 14. So because that's where they intersect, and that's what an AND means, right? Remember from the general addition rule that the AND means the overlap. That's the overlap. So because of that, then what I'm going to do is I'm going to put that 14, we'll put our 14 as our numerator, and our total of 197, people we have all together. So I'm going to use that 14 over the 197, and that is my intersection. That's the AND. And in this case, that comes out to be, I think if you round to 3 decimal places, you should get 0.71. 0.071 rather, 0.071. Alright, let me show one more example of this. Alright, how about this one? How about randomly selecting a driver who is female or has been issued one ticket? Do you see the difference between this problem and the one that we just did a second ago? This time it says, hey, how about a female or one ticket? This one said, how about a female was selected and was issued one ticket? All right, so that overlap 14 was the AND. What about the OR? Well, this I'm definitely going to need the general addition rule for this one. Okay, here, let me show it to you one more time. The general addition rule looks like this. If you want to find the probability of two things that are being ORed, right, two things that are being ORed, then find the probability of the first one, add it to the probability of the second one, and take away where they overlap. Right, take away where they overlap. Do we already know where E and F overlap? In our case, female and issued one ticket, where they overlap? Actually, we do, don't we? Yeah, we just figured that out in the previous problem here. It was 14 over 197. So this fraction in this case here, guys, is going to be 14 over 197. Now let's treat E as randomly selecting a female driver, which we actually found that earlier as well. Randomly selecting a female driver. Well, here are all the female drivers, so that's 115 out of 197. Okay, let me write that down. Right? How about randomly selecting somebody who has just been issued one ticket? Okay, so one ticket, that's a total of 21, so I'll put 21 over 197. Right? And again, don't forget to take away this 14 over 197 because that's where they overlap. That is where this row, right, this row right here, this top row, and this column here, this column overlap. They overlap right here at that 14. Okay, so we're going to take away that overlap. And if you work all of this out here, you can do this on your calculator. Add 115 to 21, take away 14, and when you divide by 197, let's see, I think that comes out to be a total of 122 over 197, if my calculations are right. And 122 over 197, if you round to 3 decimal places, comes out to 0.619. 0.619. So that's how you can use the general addition rule to help you figure out, and using maybe a table, something like this, to figure out disjoint probability events as well as non-disjoint or non-mutually exclusive probability events.